Welcome back, Algebra Express. So we are in Marecek 4.2. This section is about solving applications with systems of equations. So in this section, we're going to do a few word problems. And so the first one starts out with student activity and says, use any method to solve this, then determine whether your method involved algebra. Discuss as a class. So the sum of two numbers is 55 and the difference between them is 23. Find the two numbers. So on some of these, there might be some ways you might be able to think about them to where you don't have to set up equations. You might be able to solve them in your head is what I think they're trying to get at there. But we should set up equations. It's not going to help you a whole lot if you don't kind of get used to setting up equations. It's not going to help you on things that might be harder, right? And so getting in the habit of setting up an equation for this will be beneficial. So let's do that. And so if we want to talk about the sum of two numbers is 55. Well, we need two numbers. Okay. The sum of two numbers. So the sum is adding. So if we add two numbers, that would be 55. And if we subtract two numbers, the difference is 23. And so we've talked about solving equations with two variables, or a system of equations. And we had two methods to get at solving systems of equations. One of them was through substitution, and the other one was through elimination. And so we're looking at this, and you could really go solve it both ways. It's not really one correct way to do it, but there is a sort of way when I'm looking at this that I think might be easier. And so if I look at these and I add them straight down and try to do some elimination, they're pretty much set up to eliminate the b variable. And so if I'm looking at this is giving me a plus a, giving me 2a, b minus b. I have no more b's. I have to carry down my equal sign. 55 and 23 is 78. So if I divide 78 by 2, you get 39. Okay. And so I'm looking at this, and I know a is 39. And so I found one of the two numbers. I still have to go back and find b. So 39. Grab. And if I want to solve for b, I have to subtract 39 from both sides. So b should be giving me 16. Ooh. And I use this equation to solve for b. If I want to check it, there's another equation here I can check it in. So 39 minus 16. A minus b is going to be 39 minus 16. Is that equal to 23? And so it should check. So the two numbers, so they're actually a word problem. So probably back. So spit some words back at them. So two numbers. Two numbers are 39 and 16. Okay. So I hope number one makes some sense. We have two unknowns. We're doing the sum and we're doing the difference between them. Number two is something like we've seen already before. So I'm hoping this looks kind of familiar. Cell phone company, I guess they love their cell phone company examples. Cell phone company charges a fixed monthly rate and a per minute rate. Gavin used his phone for 381 minutes and had a monthly bill of $115.20. Dwayne used his phone for 240 minutes and had a monthly bill of $79.95. What is the fixed rate? What is the per minute rate? Okay. And so you can let your variables be kind of anything you want them to be. But there's two sort of things here that they're asking, right? What is fixed rate? What is per minute rate? So we should be getting two numbers for this thing. It should be two variable equation of some sort. That's the section we're in, so hopefully that's some kind of hint. But here they're asking, so I think I reversed the order maybe they asked them in. And so A would be my per minute rate, B would be my fixed rate. And I think I probably reversed that order because if you remember right, this is sort of like a linear equation, and our fixed rate is sort of like our y-intercept or our b variable. So I think that's probably why I went with this sort of order. Again, you can let your variables be anything. You can swap them. As long as you define your variables and you go back and you interpret what you found correctly, right? But that's why we put the definition up here. So when we get done, we can go figure out what the heck we were talking about with our variables, because we're going to do a lot of math in between defining these things and getting to the solution. Okay, so let's start this out. So I want to think about the total bill. A variable, and then my A variable, I'm going to have to multiply it by the total number of minutes, and then I'm going to have to add that fixed rate. And so this is the sort of picture I have in my head. I have a per minute rate that I have to multiply by the number of minutes that I have. And I have a fixed rate that I have to add to that. And so this is like my y-intercept. This is like kind of like my slope. This is kind of like my x variable. I'm putting in minutes to get my total bill. Okay. And so the first thing is it's 115.20. A monthly bill was 115.20 for 381 minutes. And so it's a total bill of 115, what is it, 20? And the other thing they say is a bill of $79.95 for 240 minutes. 95. And now we're looking at this. We have two equations. We have two unknowns. We want to solve this system of equations to figure out what our per minute rate is, what our base rate is. And so going back, when we're solving systems of equations, we were given two sort of routes. We could do substitution or elimination. So either way should get you the solution. The way that I went with this is I did elimination. I saw that B is already singular. It should be really sort of easy to get rid of him. It's positive here and positive here, so I have to change the sign on one of these. I changed the sign on this equation. So if I multiply this entire bottom equation by a negative, let me fix this as well. 3a times 381 is the same thing as saying 381a. And so if I just write this as a coefficient, it'll probably look a little prettier, be a little bit easier to do some operations with it. So if I do 1 equals 380. I multiplied a negative by everything here. So negative here, negative here, negative 2, here makes this. If I'm looking down here now, this is set up for elimination. Now I'm subtracting what? 115 minus 79.95. That should give me 35.25 equal to when I do 381 minus 240. That is giving me 141, and this is A. And now when I look at my B's, I have a 1B minus 1B. If you want to put plus 0 B's, you can, but you don't have to. It is gone. We have eliminated the B variable with our elimination step. So now we need to solve for A. So at this point, I'm definitely not expecting you to do this by hand. I would totally grab a calculator for this thing. It's not the prettiest thing, but it does simplify down 0.25. So it's not the worst, but not something I would do by hand personally. So we're looking at this A equals 0.25. And now I'm asking myself, what am I doing again? Oh yeah, I gotta find two variables. I have these two equations. These are my two original equations. I guess we could use these if we wanted to as well. But these look cleaner, so let's use one of these. And so I know A is 0.25. And I think I'm going to pick the one probably with the smaller numbers. So 79.95. Is equal to, and now I know A is 0.25. I know B that went with that was 240. Oh, sorry, not the B. The minutes that went with that was 240. And so I plug in A to this previous equation up here. I know A is 0.25. I can plug it in there. It should look like that when I plug A in. I have to do a quarter of 240. I believe that gives me, what, 60? I'm solving for B. I'm subtracting that 60 over, so B should be 1995. Okay. And so I'm looking at this. It is a word problem. So I'm looking back. What is A? What does it represent? So this was 25 cents, and this was a per minute rate. So this thing we're talking about per minute. This thing we're talking about in dollars. This was a flat rate. And so I should write a sentence. I don't feel like writing all of it, but the company charges $19.95 flat rate and a 25-cent per minute rate. If we want to check this thing, do a little check. So we use the 79.95 one to find our B. So let's look at this other equation. We'll bring it down a little bit. That other equation right there, 115.20. Does it check out? 20 is equal to A, 1A.25 times 381 plus B, which we found out to be 1995. So if we want to check it, we can plug A and we can plug B into that other equation. And we can check and see if that thing solves. It should absolutely solve. Okay. And so, I don't know what to say. I know, like, going back to the sort of check thing, right? I know this check looks kind of hard, but if you got a calculator, it should take you like 1 second to check it, right? If you're on a test. I'm not expecting to see your check on a test. That's something like you should just do automatically. It's like it's better to be sure than not, right? You're getting graded on that thing. I don't know what to tell you. I hope y'all did the best. So that's the page, first page. We have this one with adding, subtracting numbers. We have this one with this sort of like linear function like we've seen before. We have a base rate and we have a slope or a per minute rate there. And now we have something a little bit different. This is a student activity, so hopefully you're trying to do these on your own first. This is something, I don't know, this totally like reminds me of something I would see on some sort of meme or something. And if I saw that, like most people would be answering it totally correctly, but then you get into an algebra class and we start putting C's and J's or A's and B's and X's and Y's in there instead of putting a picture, and for some reason it just like goes blank. I don't know. So hopefully that doesn't happen, but practice and it will reduce that a little bit. Okay, so Evelyn spent 30 minutes jogging and 20 minutes cycling and burned 380 calories yesterday. So today she spent 20 minutes jogging and 40 minutes cycling and burned 440 calories. How many calories were burned for each minute of cycling and how many calories were burned for each minute of jogging? Okay, so how many things do they want us to find? So let's say like they want us to find calories burned from cycling, and then the other thing was what? Calories burned from jogging. So it looks like we're cycling and jogging, and we want to know how many calories each one of those things burns. And so you can let your variables be anything, but I let my variables be C and J because they would be kind of descriptive, hopefully. So C is the number of calories burned. Probably guessing. I should say per minute. Trying to do too many things. Look at the notes. Say the notes. And then make sure the camera's right. Okay. I said this wrong. write in pencil when you do math. Okay, so C is the number of calories burned per minute while cycling. Is the number of calories burned per Okay, same thing. I didn't feel like writing it out again. So if we do 30 minutes of jogging and 20 minutes of cycling and burn 380 calories, if we're jogging for 30 minutes and we're burning that many calories per minute while jogging and cycling, we're cycling for 20 minutes, we're burning this many calories per minute cycling. If we want to know the total calories that we're burning, we have to multiply these two things. And so this is sort of like when we're doing slopes. If we're burning so many calories per minute, we will multiply that by the number of minutes, right? We want to multiply that by the thing that's on the bottom, the word that comes after per. Okay, so 30J plus 20C, 380 calories total. And we can set up a similar equation for the next day. So 20J plus 40C is going to give me 40 calories. And now I'm looking at this. I have two equations, two unknowns. And if I want to do what, substitution or elimination, I think this is maybe set up a little bit more inclined to do elimination. So if I'm looking at these between 20 and 30J, or between 20 and 40C, okay, so if I'm doing 20 and 30, between 2 and 3, I'm thinking what, 6? So that would have to be 60. Between 20 and 40, I'm thinking like 2 and 4. I think that's the easier thing to do. So if we multiply 20 by 2, I think we'll get there. And so that's what I did. So I think I recopied this one. And I multiplied this thing by 2. So I multiplied this side, I multiplied this side. And by a negative 2. I need it to be opposite signs with this thing. So minus 2 times 30 is going to be a minus 60J. This is going to be a minus 40C. This is going to be a minus, what is that, 760? Okay, so now I'm looking at this thing. I'm adding down, so 20 minus 60 is going to give me a negative 40. And that's the J's. I don't have any more C's. That's the thing that I've eliminated. This is equal to, and this is going to give me overall a negative 320. And so now I'm solving for J. That's the only thing I have left. So when I solve for J, I divide by 40, negative 40. Should give me J is equal to 8. Okay, so J is 8. Okay, now I'm thinking, stepping back, what the heck am I doing? Okay, I was finding two different things. I started with two different equations. I found one of them. I still need to find the other one. So I started with the equation 30J plus 20C. So that was one of the first equations I wrote down. The first equation I wrote down here. And so now I'm plugging in J to find plus 240 plus 20. I'm moving the 240 over, so 20 When I subtract 240, I believe that's giving me what, 140? And C should give me 7 when I divide by 20. 140 divided by 20. Okay, so now I want to go back and figure out what the heck I'm doing. So the question was how many calories were burned for each minute of cycling and how many calories were burned for each minute of jogging. And so if we want to look at this, J is 8, C is 7. If someone asked you that question and you answered them with J equals 8, C equals 7, they would probably look at you a little strange. So answer it in some English. Jogging burns, what, 8 calories per minute? And cycling burns 7 calories per minute. Something's right. Okay. So this is very similar to something we had before. What we try to do this with a single variable. So now we're going to look at these things and do these similar problems. We're going to do them with 2 variables this time around. So the difference between 2 complementary angles is 18 degrees. Find the 2 angles. So I know I just jumped that gun a little bit. So review right back. Supplementary is a sum of 180. Complementary is a sum of 90. And a triangle is a sum of 180. So hopefully you already have those kind of memorized. I don't like to say memorized, but that is vocabulary. I guess you have to memorize vocabulary. And so we want 2 angles. There's 2 angles that we want to talk about. And so you can let them be anything you want. But I let them be of X and Y. And I guess I got super specific in my notes. But I think it's important to maybe be specific about what you're doing. The measure of the first angle in degrees, and then Y is going to be the measure of the second angle. So I know I have 2 angles. I know the difference between 2 complementary angles is 18 degrees. So first thing, I want to focus on this thing. They are complementary. So what does that tell me? It tells me something like if I add the 2, they should be 90. And then the next thing says the difference between them is 18 degrees. So I know one subtracting the other, the difference, if I take the difference between them, if I subtract one from the other, that should be 18. And so I have this. There is actually something I kind of did that might be worth noting. When I did the subtraction and the difference, I did kind of define X to be kind of like the larger one. It might be worth noting that it happened. And that's just kind of how I set up the equation. If I set up the equation the other way, Y minus X, I'm going to get the same 2 angles, but they're just going to sort of flip. So I define my thing, I define my variables, I got my equations down, and now I'm thinking I have 2 equations, 2 unknowns. What do I want to do with these things? I want to solve them through substitution or elimination. So I'm looking at these things. I want to go substitution or elimination. To be honest, this one's probably equally as difficult either way. So let's go, I think it's just set up right there. If I draw a line down there, I can do elimination real quick, and I believe that's what I did in my notes. But here I have x and x. It's going to give me 2x's. This is going to give me no more y's. This I gotta bring down equal sign. 90 and 18 is going to give me 108. X is 108. Then a single x should give me 54. So I have one angle. I have two equations I can kind of go plug it back into and figure out the other one. So 54 plus y equals 90. That's making use that they are complementary. And if I do that, 90 minus 54 will give me 36. And I said, no, my two angles are what? 54 and 36. So these are degrees, I guess I just put them. Okay. Okay, so the angles are 54 degrees and 36 degrees. If I want to go back and check it, how do I check this? I check it by putting it into the other equation. So x minus y, 54 minus 36, does it check the difference is 18? It definitely should. Okay, and then the next one is pretty similar. We're still talking about complementary angles. So two angles are complementary. Find the measure of the angle. Find the measure of the angles if the larger of the two angles is 15 degrees more than 2 times the smaller angle. So that is a mouthful, and we'll go back and look at that. But we know we still need two angles, so I'm going to just continue with x and y. So I have x and y. They are complementary. So let's put that down first. X and y are complementary. It looks like x plus y is equal to 90. Find the measure of the angles if the larger of the two angles. So I didn't really define which one is larger yet. I can really do either one. So one of the angles, let's just say x. The larger of the two angles is equals 15 degrees more than 2 times the smaller angle. I know 15 degrees more. Looks like I'm going to add 15 degrees to something. 2 times the smaller angle. 2 times the other thing that I didn't use, the other variable, is my y. And so now if I'm looking at this, I have my equation set up. I know x is one of my angles. It is the larger angle. Y is the smaller angle. I defined it with this one. And so now I know I want to do substitution or elimination. I think this one is set up like straight for substitution is how I'm going to do this one. So I know I've been doing a lot of elimination, but this one gives you x equals 2y minus 15. I can plug that in anywhere there is an x. So that is taking the place of that. Plugging it in 2y plus 15. So I think this side is giving me 3y plus 15 is equal to 90. When I subtract 15 from both sides, I can get something like 3y is equal to 75. And you might figure out a single y would be 25. So if y is 25, and we go back to these two equations we have, we want to figure out what x is. We can plug it in either one of these. But when we have a substitution step, typically I go with the one that looks like the thing we substituted. So x equals 2y plus 15. X equals 2 times 25 plus 15. 2 times 25 is 50 plus 15. I'm going to just do this all in one step. That should give you 65. So I know one is 65 degrees, and I know one is 25 degrees. That's it, right? Yeah. One's 25 degrees, one's 65 degrees. If I want to check it, the thing I can do to check it, I can check that first equation I had written down there. Are those going to add to 90? Are they complementary? They definitely are. Okay, so now we're going to get to motion applications. So before we even look at this problem, I want to think about, like, I don't know if y'all do this in your head. I know I definitely do this in my head a little bit. If I'm driving 65 miles right, this is going to be my rate that I'm traveling at. I'm traveling at a rate of 65 miles per hour. How far have I driven? If I drive 2 hours, or if I drive 3 hours, how far have I driven? So if I drive 1 hour, I'm going to drive 65 miles. If I'm driving for 2 hours, I'm driving 65 and 65, 130. If I do 3 hours, I'm doing 65. And so just going back to what we're doing, if we want to find distance, we got that by multiplying our rate by our time. And so sometimes you might see D equals R times T. And so for these next problems, this is absolutely what I'm going to suggest you do. Like, you're going to write D equals R times T, and then we're going to make boxes for these. And this is the best way that we can kind of set these things up. And setting up this diagram will really help you understand the relationship that's happening. There's a lot of information they're about to spit out at you, and these things will help you organize things in your head. So, with that said, let's start with this thing. So at the end of spring break, Lucy left the beach and drove back towards home at a rate of 40 miles per hour. Maria left half an hour later and drove 50 miles per hour. How long did it take Maria to catch up to Lucy? So like I said, rate times time. We're going to create a table. We're going to create a table for two different people. I want to create a table for Lucy and Maria. And so for Lucy, they're giving us the rate. They're giving us the rate is 40 miles per hour. For Maria, they're giving us her rate is 50 miles per hour. And so I think those two, I think they kind of fill in themselves. If you understand the table, you understand Lucy's rate is 40 miles an hour. Maria's is 50. The question is, how long did it take Maria to catch up to Lucy? And there are multiple ways to do this problem. You can define your variables a little bit differently. But if this is what they're asking, how long did it take Maria? This is the thing I want to fill in. I'm going to let this be my t variable. And if Maria is driving at a rate of 50 for t hours, 50 miles per hour for t hours, her distance is going to be r times t. It's going to be 50 times t. So if we want, we could put 50t in that box. Now we want to step back. Maria left half an hour later. So she left half an hour later than Lucy. So if we think about how long Lucy was there, I'll give you to account for that hour and a half. So I need to put a sign, and I'll give you a hint. It's either plus or minus, and I want you to really think about this. Is it going to be plus or minus? So was Lucy on the road for more time or less time than Maria? I think is what the question is, right? Ooh, I didn't even realize how horrible this was. We're going to change this. She left an hour. 1.5 is what I did in my notes. We're continuing with that. Let's do it that way. I didn't realize how horribly worded that was until I really reread it. Maria left half an hour. Ooh. I want to do an hour and a half. And so we're thinking about this. If she left an hour and a half later, Lucy was on the road for an hour and a half more. She was an hour and a half, and then plus whatever Maria drove to catch up to her. And now if we look at her distance is 40 times t plus 1.5. And now we're looking at this. We know their distance, we know their rate, we know their time. It has some variables in there. But they're saying how long did it take Maria to catch up to Lucy? So if you catch up to someone, what does that mean? Does that mean your rates are the same, your distance are the same, or your time is the same? So that absolutely means you're going to be the same distance. You have driven the same distance means you are at the same place. That's synonymous. So in order for them to be at the same distance, these two distances have to be equals to each other. So we're setting up an equation that looks like 40 times t plus 1.5 is equal to 50. And so now I have a single variable equation. We should be able to solve a single variable equation. So 40t plus, was it 40 and a half? 60 equals 50t equals 10t. So I believe t is equal to 6. Okay, and if t equals 6, interpreting this, it took Maria 6 hours is what this is saying. To Lucy, I guess I could say. Okay. So there are other ways you could set this up. If you let Lucy's time be t, this would have to be like t minus 1.5. That's another way you could do it, but you'd have to remember how you define your variables. A little bit at that, maybe if I asked you, it took Maria 6 hours to catch up. That I know because t was Maria's time. But if I wanted to know Lucy's time, how long was Lucy on the road? I would have to figure out t plus 1.5. Which is 6 plus 1.5, which is 7.5. So they asked you for Lucy, which is absolutely something they might do or could do. We could also figure that out, right? If we wanted to know their distance, we have to go, what, 50 by 6 would be, what, 300 miles? I think they caught up to each other at 300 miles. We could figure that out as well. Okay, so this table really will help you organize things. And so this is a student activity, so you should be trying to do these by yourself. And so do it with a table. So a runner heads north on a highway jogging at 10 miles per hour. Half an hour later, that sounds better. Half an hour later, a driver heads north on the same highway to pick up the runner. So if a car travels at 55 miles per hour, how much time will it take for the driver to reach the runner? Round your answer to the nearest minute. Okay, so something kind of annoying is we might get some fractions here, but it is very similar to the previous problem, right? We have distance equals 8 times time. Draw our box. Okay. We know there is a jogger and there is a car. We know the jogger's going 10 miles per hour. We know the car is going 55 miles per hour. That is their we want to know how long it will take the driver to reach the runner. So the person's time who we want to figure out is the driver. So the easiest thing to do is let that thing be your t. Now we want to figure out the jogger was on the road for half an hour, more or less. Half an hour more than the driver was. He has a head start on the driver. Now, if we're looking at this thing, if I want the driver's distance, it will be 55 times t will give me 55t. So that tends to be the easier one for students to get a hold of. This other one is the same thing. Ten times t plus 0.5. And so if I'm looking at these two things, I want their distances to be the same. So 10 times t plus 0.5 is going to be equal to 55t. And now I do some distribution. 10t plus 5 is equal to 55t. 5 is equal to 45t. And this is where we're getting at 45 over 5. 1/9 of an hour. Okay, so if we're talking about 1/9 of an hour, they asked us how much time will it take the driver to reach the runner round to the nearest minute. So they asked us for minutes. So if we know it's 1/9 of an hour, we can do 1/9 of 60 minutes to convert to minutes. And this is like 6.6 repeating or something. It should be 7 minutes. All right. So I know these are going to take some practice. So hopefully you come to class prepared to do some work. These things, they're set up kind of crazy. I don't know what to tell you, but it's kind of crazy. If we want to do, I don't know, we could figure out, that's kind of a nasty question. If it took them 7 minutes and it took this guy, what, half an hour longer? I think it took him, what, 37 minutes to run? Yeesh, it's not the best thing to do. Not the best thing to throw out at you. But these things really help you with the structure. I think this one is a little bit prettier, probably. They try to up the ante a little bit with each problem. So it took 7 minutes. Maybe I should write a sentence. It took 7 minutes. It took the driver 7 minutes. Okay. And that's it. Come to class. Be prepared. See you soon.